Everyone. In my previous video, I spoke about image classification, and today we will see how to detect objects in any given image. Both classification and object detection relies on tagging, but the difference between these two is object detection actually works on the coordinate system, whereas we will create a boundary across the object and will say that this particular boundary contains this type of object. Now, before proceeding ahead, I would like to mention that in this video, neither I will be covering the basics of image analysis nor I will be talking about the important terms like tagging, precision and recall, as I have already covered these in my previous videos. So if you have not watched those yet, I would recommend you to go back and first watch those out. Having said that, let's have a look at one of the picture. So this is the picture which contains vegetables and fruits. So tomatoes, cucumber, radish, all these can be taken as an object. So this image consists of many objects, right? All these vegetables, fruits can be considered as a single object. And for any particular image to be considered as a single object, it has to have its boundary. So let's say this particular cucumber, if I am drawing a particular rectangle box or anything, it should contain my entire cucumber inside this. So this is how we will see in this session that how we can detect individual objects in an image where we have so many other objects beside that. Okay. So for that, let's go ahead and log into our custom vision. So this is the custom vision AI portal, and I will go ahead and log in onto this. So as I said before, you have to use your same Azure credentials when doing the login. Okay, so we are here and I will go ahead and click on new project. So here you can mention the name of your project. Let's say I'm giving object detection. You can provide description. It is completely optional. And here comes the resource. So this is the same resource which is created in our Azure portal last time. So if you want to know how to create, then again you have to refer back to my video. So for me it is already appearing this, so I am selecting it. Next comes the project type. So here we are doing object detection. So I will be choosing this one, and I would prefer to go ahead with general category this time. Click on create. Okay, so it is almost the same portal with almost same options. So I will go ahead and try to add one image and will show you how we can draw boundaries. So let's say if I click on, so these are the pictures which I have taken. Maybe I can quickly show you. So I have already collected certain pictures. So these are the buses, and here I have certain images of cars. So in this demo we will be detecting that which all are cars and which all are buses. So for that I will go ahead and click this bus picture and will take it as an image for the training. Now I have already added the image. Next thing I need to do is the tagging part, right? So for tagging, like I said, it works on the boundary concept. So we need to identify a boundary in which this bus can fit. So on the right hand side you can see that dotted box, so you can click, and as soon as you will click and then you will come back to a picture, you will be able to draw such kind of rectangle. And once this rectangle is drawn, you can stretch it, you can shrink it, you can try to fix the border wherever you want. Now I want to label this particular type of image as in bus. So here I can quickly type it. Now if you will see, this particular area, it is identifying as a bus. So next time if you will upload any such image for your testing, it will say that, oh, it's bus. Right, so in this manner we need to upload all the images, and again I would say the more the images we have, the clearer the pictures we have, we will get the better results. So in this video I am not spending time to train the model or upload the images, that it is a very time consuming operation. It may take beyond 20 to 30 minutes. So in order to save time, I am opening one of the existing project which I have already created, and here I can show you. So there on the left hand side, buses, 17 buses. So these all pictures I have added as a training set. Similarly for car, I have added all these types of pictures. So if I'm testing it, then I should be able to detect the correct car based on all these training set images. Now coming on to the performance side. So here you can see that as initially started with first iteration wherein I took 15 images of car and 15 of bus, and I was ending up with the precision of 85.7% and recall of 100. Then I modified the model a bit. I trained with one more image. Still I was at 85.7. Then I tried to do some more tagging. I removed some of the images which were not clear, which were not identified correctly, and unfortunately I end up with lower precision. Then with some more correct images, ultimately I was able to get the precision of 100, recall of 100, and AP of 100. So this is how we need to train our model and see how it works. Now, the one thing you will see that in case of object detection, there is one additional parameter on the left hand side. So there are two sliders this time. In case of image classification, there was only one slider, probability threshold. Right. So to summarize, probability threshold depicts the minimum confidence score that any prediction must have. So that if we are reaching the prediction of 50%, then we will say that our prediction is correct. Right. At the same time, coming on to the overlap threshold. So it talks about the overlapping area between the bounded box of the predicted object and the actual object. So that if overlapping doesn't happen in this criteria, let's say if 30% of the area is not overlapped, then we will not consider it as a correct prediction. So I can quickly show you using one small diagram. So let's take this one and I will draw some text here. So let's say this is train, and let's consider this particular image as a training set. So this is my training set. Again, I am trying to write something TR. So this is the image I am using for testing. So above one is training set, below one is testing. So if I will try to test my model with TR, it will not meet my prediction level or the overlap criteria because this TR is not even 30% of this, right? So if I want to be successful, then 30% area has to be overlapped. Now let's say if I go ahead and try my testing image as TRAI. In this case, you can see that more than 30% area is overlapped. So it will say that, oh, this particular thing we are talking about is train. And this is how object detection works. Now let's try out a few of the images so that we will get to know how it detects. So first of all, I will take one picture, this image. So we can see that it is using my iteration 4 and it is trying to analyze all the objects in this image. And so once this analysis process is done, you will see the red square and the rectangles around all these pictures, all these objects, sorry. It will take a few seconds. Okay. Now, these all rectangles depicts that it has detected something. And if you will look at the bottom right side, so it is saying that predicted threshold is 15. So if threshold is 15, then only we will see something in our result, right? And on the bottom, you can see that predictions are shown in red. So although rectangles are marked in red on the left hand side, still we will go ahead and read the bottom part here. So let's scroll this scroll bar on the bottom right, and you can see that there are some objects identified, car, bus, and all these things. So let's go ahead and see. So this particular object, it identifies that it is 95% chance that this is bus. this is car, again this is car, this is car, this is bus. Oops, so this object, although it is a car, my model is saying that it is a bus, and that too with 68.3% as a confidence score. So now we know that this is not bus, it is a car, which means that we need to train our model with more images with such sort of car, with this type of angle, the way it is standing here. So next time whenever you will predict or test it, you will get much more better results. But most of the vehicles you can see that it identified clearly. So bus, although it's a truck, but it is saying bus because I have used this image as a bus in my training set. Again, this is a car. So this is how it works. Let's try with one of the image which doesn't fall in this category. So this is the picture of an animal. Let it analyze it. Okay, so now again you can see that this time on bottom right there is nothing. I couldn't see any value of tag or probability, right? There is no scroll bar on the right hand side. So it means although red rectangle is detected, but it is not meeting my threshold value. Right, so it means this object is falling outside my categorized tags. Neither it is bus nor it is car, right? So this is how we can filter it. Now the next important thing I would like to show is, let's talk about this particular image. Okay, so this is the image which was wrongly identified. Now how can we rectify it? So one way to do is, let's go ahead and tag it here itself. So if I will select it here, I can go ahead and instead of bus, I can make it as a car. Okay, so now next time whenever we will use this particular type of image for testing, it will surely give us that it is a car. I will close this dialog. Now, if I will again test it, it's not going to work because I have to retrain my model, right? So once it is retrained, things will be all good and the images would be detected properly. So this is how things work. We have to keep training our model as and when we identify new type of objects which are not as per expectation in that category, right? Now, the one more important thing I would like to tell is there are few drawbacks, or I would say limitations, which we cannot work with this object detection API. So let's talk about those. The first one is the contextual information. Let's say you would like to identify given image is indoor or outdoor image. So such things we cannot detect using object detection APIs because it doesn't work on a context. It works on the boundary boxes, right? So if you are looking for some contextual information, it is always good to move back to the classification model which we discussed earlier, right? Tagging APIs. Next comes the objects which are too close. Let's say you place certain objects in a stacked form. Let's say there are hundreds of books on top of each other, or there are 20 to 30 plates on top of each other. In that case, this object detection API will not at all detect because those objects are too close to draw a boundary across them, right? And the third one is, it doesn't categorize based on the name or the brand because this is again tagging. This is again, if you want to know which brand it is, then you have to move back to your classification model, the classifier, rather than coming on to the object detection part. So this is how it works, and that's all I have in my plate for today. Hope you enjoyed learning object detection using Azure Computer Vision, and feel free to share this video and subscribe it so you do not miss my future videos. Thanks for watching.